here's part 4. They're asking in this question 2 pairs of identical cards. So again, we have 2 pairs of identical cards, 4 boxes. We have 4 boxes there. We have A, B, C, D, E, F, G. And we have a 7 out of 7 chance of getting a card in that first one. And then to get an identical card, we have to multiply by 1 over 7, right? It's going to have to multiply. It's going to have to be the same one. Then we have how many choices, because we need a second pair. It's going to be 6 out of 7 choices we can choose from B, C, D, E, F, G. So in our tree diagram, that's going to go to B dot 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 all the way to G, right? And then we are going to we need a fourth card, which has to be identical again because it's 2 pairs of identical cards. So it's going to be 1 over 7. So it's no choice. It's going to have to be B. Okay. Now, right here, this is, doesn't have to be A, A, B, B. We can get this in different orders, right? So we have 4 different letters, or 4 different slots here. And of those 2 slots, those 4 slots, 2 of them are identical, so we got divided by 2 factorial, but divided by 2 factorial. And again, we have to be careful here. See later down on in this diagram down here, we have B, B, so 7 out of 7 chances getting a B. Sorry, yes. And then if we draw a B first, and there's a 1 in 7 chance of getting a B second, and then we're counting 6 out of 7, which means this starts with A, then C, all the way down to G. Those are our 6 choices. And then times 1, which means it has to be the same thing over here, which means that this is A as well. So do you see how this is A, and B, and B, and A have, I guess, kind of repeated here? So we've over-counted how many different ways we can get that. So we got to divide by 2 again. So that we don't overcount the number of ways we can get the thing. So if we plug this in our calculator, it's going to be 7 times 6 times 4 factorial divided by 7 to the power of 4 divided by 8. Try that again. 7 times, okay, let's simplify this. 7 over 7 is just gone, so it's just going to be 1 times 6 times 1. It's going to be 6 times, 6 times 4 times 3 times 2 times 1 over 7 to the power of 3 times 2 times 2 times 2. So this divides out, and we're left with 18 over 243. Okay. Sorry, 343. All right, so that's method number 1. Method number 2 is we have, again, we have 4 slots, and we got to choose 2 of them for our AAs. So there are 4 choose 2 ways of placing A's here, 2 of our A's, and how we're going to place the B's. We just multiply by 1. There's 1 way of placing the B's afterwards for each for each AA that we have. Okay, so look in the previous or 2 previous ones about how to get what this 4 choose 2 means. Previous example, sorry. And then we have, so now that we have 4, we've chosen the number of ways that we've chosen our slots here. We gotta choose the number of ways we can, which letters we can choose. So we have 7 choose 2 ways. We gotta choose 2 letters. We have 7 letters, choose 2 of them. So we have 4 slots, choose 2 of them. That's the number of ways of placing these things. And we have 7 choose 2 items to place in there. And then you divide by 7 to the power of 4. I believe that should be the same. So 4 choose 2 is 6 times 7, choose 2, which is 100. Wow. My writing's going to be super good now. All right, 126 over 7 to the power of 4. 7 power of 4, 2401. Gonna put that in those terms. So 126, hopefully it's the same thing. 2401 is 18 over 343. Okay. So as you can see, in the very first example, you guys didn't like the use of combinations or combinatorics. But when you use combinatorics, you can see that there's no overcounting. Over here, when you start doing the probabilities here, there's chances are you're going to start overcounting, and it's really hard to catch. The hardest part was this part for me, right? Seeing that these things repeat twice, and you're overcounting. So you got to divide by 2 there. So in the simpler examples, it would look kind of extra to use the combinatorics. But as you can see in the last couple examples, combinatorics is actually simpler. There's no overcounting. You can get the answer a little bit faster. But, and again, it's important to be able to see things in with different lenses, and it'll improve your understanding of what's happening here. And again, it separates us from the computer, because the computer will only do it one way, which is the effective way. But sometimes it's important to look at things in a probabilistic way as well. Okay, let's go on to the next video.